Hello, welcome to our mini lesson. And so what I'm going to cover is what we talked about this week. So starting from Monday to Friday, what we talked about this week in science. And so this is your mini lesson on magnetic fields and forces. For some of you, this will be part review and part new things. And so keep an ear out for those new things so that you can add them to your notes. And so we are going to be filling out a couple of things on our notes today. The first is we are going to get almost all of the vocab, 4 out of 5 things today. So we're going to talk about attraction, repulsion, magnetic poles, magnetic fields, and then we're going to leave electromagnet for later. Then we're going to talk about the magnet rules, and we're going to get 2 of these rules today. So the first 2 are going to be about the magnets can, and so that's going to be some basic properties about what magnets can do. The second part is going to be filling in the blank, talking about the magnetic poles, and we're going to fill this all in together. So as you're watching this short mini lesson, it would be helpful to have split screen on one side and your notes on the other so that you can pause the video and type your notes out, restart it, pause, type, and that kind of thing. Okay, so the first vocab word that we're going to talk about is attract. And this is referring to magnets that are attracting either other magnets or other metals. That's to pull objects toward one another. And so you're going to be writing this down on your note page in the vocabulary section. And so that should be in your vocab. I believe for you guys, it might be the second word, first or second word, but fill in the definition for attract. And so in this picture, you can see that there are magnets here, and they have different poles. And so what this is showing us is that unlike poles, so a north and a south are going to attract one another, whereas like poles are going to repel. And so that's the word we're going to be using for magnets that are coming together or connecting. Or if you think about a magnet on a refrigerator, the magnet is sticking to the fridge, right? And so that means that those two objects are attracting each other. The next word is repel. So that's to push objects away from each other. And so in this image, we see that there are like poles on the magnets. They're flipped the same way. And so they're going to repel each other because the poles don't like to touch. They're not friends. They are totally passing on each other. And so they do not want to be next to each other. They're repelling. So to push objects away from each other. Go ahead and add this to your notes on your Google Docs page. And if you need to pause this video to write things down, you're more than welcome to do that. Just a reminder. Okay, the next vocab word that we're filling in is magnetic pole. Now, this is one of the most important things to understand about magnets is that there's a north and a south pole, and depending on what way the magnet is facing, these poles are the reason why they affect objects differently. And so that is one of 2 opposite ends of a magnet. So go ahead and add this in your notes as well. Okay, that brings us to our first magnet rule. Now this is going to go under the magnet rules in the first dash. And this is magnets can attract or repel an object at a distance. And so if you think about if you have a magnet in front of you and then you have a paper clip, you can hover that magnet over the paper clip and pick it up. You don't have to actually touch the magnet to the paper clip to pick it up all the time. And so magnetic forces can act on an object at a distance. So you're adding this to your notes. And so here's just kind of a way to visualize that concept again. If you notice, the person holding the magnet is never touching the magnet down to the ones on the table, but they're attracting the other magnets from a distance. And so you can see they're coming up and those magnetic forces are acting from a distance. And so now the question is, what do you think causes these magnetic poles to either attract or repel? That's what we're going to talk about next. So that brings us to our next vocabulary word, magnetic field. And that's the space around a magnet in which magnetic forces can act on objects. And so if an object is within that field of force, then the magnet can act on it. So that's why if you have a paper clip and you have a magnet, you have to get the magnet a certain distance away from the paper clip in order for it to act on it or for it to pick it up. So magnetic field. And this image right here is actually what the Earth's magnetic field lines look like. So you can see them coming out of one of the poles and back in. So magnet fields are actually a closed loop. They come from the North Pole and to the South Pole and vice versa. They kind of go in this continuous loop. So again, you're adding this to your vocab section on your notes. And so this brings us to kind of some more detail about what these field lines do and what they mean. So the north and south magnetic fields are equal in strength. No pole is stronger than the other, but the closer you get to either pole, the stronger the magnetic field is going to be. And so you can see that these lines are more concentrated as you get closer to the end of the magnet. And the farther you go from the magnet, the more far apart the lines get. And that means that they're less concentrated. And a less concentrated magnetic line is going to be a weaker force, whereas the more concentrated lines close to the magnet are going to have a stronger force. So that brings us to our last magnets can rule. Magnets can be stronger or weaker depending on closeness to the magnet. So the closer you are to the magnet, the stronger the force is going to be. The weaker the magnet, or sorry, the weaker the force, the farther you are from the magnet. So go ahead and add this to the second dash on the magnets can section. And this brings us to our final magnet rule that we're going to be filling out today. And that is that magnets are always blank when like poles are next to each other and blank when opposite poles are next to each other. And if we check out this picture here up at the top, you can see that the unlike is what attracts. And so whenever poles are opposite or different, they're going to be attracting each other. And so magnets that are opposite poles will always be attracting, whereas magnets that have the same poles facing each other, so north and north or south and south, those are always going to be repelling each other. And so they're going away. And so you are filling in those blank words here. So magnets are always repelling when like poles are next to each other and attracting when opposite poles are next to each other. So you're going and filling in those blank spots on magnet rule number 2. Oops. And so now, what do you think creates these magnetic fields? How do these come about and what starts a magnetic field? So what we're going to do is take a look at the simulation in Amplify. You can find this in the Magnetic Fields Unit, Chapter 1, Lesson 1.2. So I'm going to fill that or get that up really quick. Quick note, this is not an assignment you have to do in Amplify. We're just kind of playing around with the simulation right now. And I want to encourage you guys to open this up on your own and just kind of play around with the buttons. So the first thing that I'm going to do in this simulation is I'm going to turn on the field lines. Then I'm going to start dragging and dropping magnets. So as you can see, those green lines are representing the field lines. And so they're going out from the magnet and then coming back in. And the closer they are to the magnet, the closer the lines are together, the stronger the force. The farther the lines are, the weaker the force. And so if I put a magnet way over here, and then put another magnet over here, first off, you can see that they're like poles, and so they're repelling each other. But if I flip them, so now they're opposite poles, you can see that those magnetic forces are starting to combine. They're starting to attract. And so if I hit the run button up here, you can see that these magnets are starting to move closer to each other very slowly, but those magnetic forces are moving towards each other. And as they get closer and closer, they're going to start moving faster and faster because the field lines are getting stronger. They're getting more concentrated, and now they're combined. And so that's an example of how those magnetic field lines are weaker as the magnets are far apart, but the closer they get, the stronger they get and the faster they go. Whereas if we were to flip this magnet, so now the field lines are repelling. Let's see what would happen if we put them really close together. Okay, so they moved away from each other pretty fast. So I want to see that again. So they started out touching, and then they kind of bounced away from each other because they did not like being next to their like pole. And so they moved away from each other. Okay, and so that's what those magnetic field lines look like. And so I wanted you guys to see just a visualization of that. So now I'm going to go back over here. And so what causes these magnetic field lines? And the answer is electrical currents. And so if you have an electrical current that's going in a circular motion, it's going to create a magnetic field. And that's what we have in the earth. So magma in the earth's core holds liquid metal. And as that liquid metal is creating currents in the earth's core, it's going in a circular motion. It creates an electric current, and that's what builds the magnetic field around the earth. And so anytime you have a loop of wire or you have a current in a wire, it's going to create magnetic forces. And so this is where we're kind of leaving off here. We are going to be talking about electromagnets because this electric force that's building the magnetic field, it's built by electrons. That's going to lead us into what an electromagnet is. And we're going to talk about that next week. So stay tuned for another mini lesson on that. And with that, we are done with the mini lesson. Feel free to go back and re-listen to any parts of it. If you want to email me with any questions, I would be happy to answer those questions. But otherwise, I'll see you guys in class and see ya.